Okay, so previously we looked at a video factoring by trial and error, but all of the problems that we looked at had a leading coefficient of 1. So today I want to make a video about what to do when the leading coefficient isn't a 1. So for example, let's jump into a problem. 3y squared plus 8y plus 5. Alright, so the idea here is we want to try to break this down into a set of binomial factors. In other words, we're going to have a term, a term, a term, a term. So they both have two terms in there. So the idea here is you start off by thinking about, well, what could you multiply together to give you 3y squared? Well, generally, it's going to work out to be something like this, 3y and y. It's very rarely going to be 3y squared and 1. You won't see that one a whole lot. So we know 3y and y gives us the 3y squared. Now I want to think about what would multiply to give you 5. Well, it could be a 1 and a 5, or it could be a 5 and a 1. And here's where the trial comes in, is because you have to try a couple different options here. Let's see what happens if we put the 1 there and the 5 here. Well, doing that, we would get 3 times 5, which would be 15y, and then on the inside we'd get 1y. And if I add those together, I could get 16y, and if I subtract them, I could get 14y, but neither one of those numbers is 8y. So the 1 and 5 didn't work out quite the way I wanted it to, so let's switch it around and try 5 and a 1. Well, this way, 3 times 1 is 3y, and 5 times y is 5y, and if I add those together, I get my magical 8y that I had up here in the middle. So if they're both positive, in other words, this will be the solution set, okay? So sometimes you don't get it right the first time, and the more practice you get with these, the better you'll be. So for example, looking at another one, 7a squared plus 22a plus 3. So again, we know that 7a and a multiply to give you the 7a squared. I also know that 7 times 3, if I put my 3 here, would give me 21, which is pretty close to what I have there in the middle. So let's try 3 and 1, because 1 times 3 gives you the 3 you have on the end. And then multiply the outside together, multiply the inside together, and notice that if you add them together, you would get the 22 in the middle. So again, they're both positive. Okay? However, not every problem is going to have plus and plus. Sometimes the signs get mixed up. For example, here we have this problem. Okay? And this also leads to having more possibilities that we can try. So here, 8m squared, well, that could be 8m and 1m, or it could be 4 and 2. So just as a rule, it's usually faster if you start by checking the numbers that are closer together. In this case, 4 and 2 are closer together than 8 and 1 would be. That's just typically how it works out. It's not always the case. And then note that 4 times 3 would give you 12m, and 1 times 2 would give you 2m, and if you had a negative 12 and a positive 2, that would give you the negative 10 that we see in the middle here. Okay, so you want to get a negative on the 12 part, the outside, and a positive on the 2 part on the inside. So here's how that one would factor. Okay, let's look at another one. 6p squared minus p minus 2. Alright, so again, 6 could be 6 and 1, or it could be 3 and 2. Let's start off trying the 3 and 2 route. Note that 2 times 2 would give me 4, and 3 times 1 would give me 3. Again, note that 2 times 1 gives me the 2 I have there. Notice that I have a minus and a minus. So if I have a minus on the end, that means that one of my numbers here has to be negative. Note that negative 4 plus 3 gives me negative 1, and that's what my coefficient is in the middle. So if I have a negative on the part that gives me the 4 and a positive on the part that gives me the 3, then my signs will work out. Alright, let's look at another complicated example. They won't always be nice and pretty numbers. Sometimes you get nasty fractions. In this case, we have fractions in the exponents. So the first thing we want to do in this problem is go through and pull out the greatest common factor, the biggest thing that goes into all three of these terms. So notice that 4, 8, and 3, they don't share any factors. 3 is prime, and 4 is only 2 and 2. So there's no numerical GCF there. However, they all have an x. So it looks like the smallest exponent we have is an x to the 1/4. So always start by pulling out the GCF first if it exists. So, and remember that also when you're pulling out a GCF, you're doing division. And when you're dividing things with exponents, you have to subtract the exponents. So 9/4 minus 1/4 would be 8/4, which is 2. Then in the middle, 5/4 minus 1/4 would be 4/4, which is 1. And finally, 1/4 minus 1/4 is no fourths, so we don't have to write an x on that one. And then it looks like what's left over here will probably factor with trial and error. So let's see, let's try 2x and 2x and 3 and 1. So 2 and 3 gives me 6. 1 and 2 gives me 2. If I add that together, I'll get the 8 that I have in the middle. Okay, so there's how you work that problem. Okay, I got a couple more problems here that I want to go through, because these are the kind of the hardest things people have trouble with, because there's so many different ways that you can work the problem, so many different things you can guess. So here we have 2n plus 15 plus 7n to the negative 1. Again, always try to pull out a GCF first, which is usually the smallest exponent you have. Notice that the 15 is the same thing as 15n to the 0, like this. And then the smallest exponent, well, negative 1 is smaller than 0, so here we can pull out an n to the negative 1. And so n to the first divided by n to the negative 1, we subtract the exponents. 1 minus a negative 1 would be a 2. In the middle, 0 minus a negative 1 would be n to the first. And negative 1 minus a negative 1 would be 0. So the n's cancel on the end. So two things we can do here. I don't like to leave negative exponents, so we can make that 1 over n. And then we can also do some guess and check, or trial and error, whatever you want to call it here, and see that the second part there will factor like this. 2 times 7 is 14. 1 times n is 1n. And 14n plus 1n would give me the 15n that I have in the middle. So always when you're factoring, be sure you go back and check your answer when you're done, because it's really easy to make silly mistakes. And there's really no reason to get a factoring problem wrong, because you can always check your answer and you'll know immediately whether you did it correctly or not. Okay. I got 2 more problems here that I want to work through. One of them is a U sub problem, where we use the letter U. We're going to substitute U in for all of these binomials that we have. So these n plus 1s, we're going to replace those with U's. Alright, so our problem goes from this to 5u squared minus 17u plus 6. And really the only reason we do that is to make the problem a little bit nicer to look at. You're more than welcome to, if you can picture this as one collective term, to factor it just the way it is. Personally, if I was working the problem, I would not do a U substitution. But it's a nice little trick, and it helps students to visualize the problem that you're looking at. So here, Again, 5u and u are really the only things that are going to give you 5u squared, but 6 could be 3 and 2, or it could be 6 and 1. So I know that 5 times 3 gives me 15, which is pretty close to this number. And if I added 2, I'd get a positive 17. But note that my sign on the end here is positive, and my sign in the middle is negative. And the only way that can happen is if I have a negative and a negative. So negative times negative, negative 2 times negative 3 gives me positive 6. And then 5 times negative 3 would be negative 15, plus the negative 2 would give me the negative 17 that I have in the middle. So there's how you factor 5u squared minus 17u plus 6. But this wasn't the problem we started off with. So anytime you're doing a u substitution like we did here, be sure that you go back and plug in what u is equal to. So in this case, u was equal to n plus 1. Alright, so we'd have this. And then sometimes people just want to go and try to reduce and simplify stuff down. In this case, that's not such a big deal. So we'd get 5n plus 3 times n minus 2. Okay, something like this. Just a nice little note, another way you could solve this exact same problem would be to go through and multiply this out, n plus 1 squared. You'd get n squared plus 2n plus 1, and distribute the 5. Distribute here and combine all your like terms, and then take that trinomial and factor it, and it should factor like this. So you can get the same answer doing multiplication if you're not comfortable with doing the u substitution. Alright, so one more problem here. Let's do one that looks like this. 2 minus w minus 21w squared. Alright, so notice here that normally we have the variable squared on the first term and not on the last term, but there's no real big difference here. We can factor it just the way it is. So we know that 2 and 1 multiply to give you the 2 in the middle. And 21 is probably going to be 7w and 3w, because 2 times 3 gives me 6, and 7 times 1 gives me 7. And if I had 6 minus 7, that would give me the negative 1 in the middle. Okay, so the minus 7 and then the positive on the 6 part. So there's how you factor that. Be careful when you're factoring. Sometimes you will get an answer that no matter what combination of numbers you try, it doesn't work. If that's the case, the answer would be prime. I haven't worked any examples of that here, because usually the trial and error that doesn't have a coefficient of 1, they're lengthy to try as it is. So making a prime problem is just kind of cruel. So, alright, so there's trial and error. If you need any help, feel free to leave a comment below. Otherwise, good luck.